0.1a is right triangle trigonometry. So this is basically just SOHCAHTOA. Start out with a right triangle and an angle theta. The theta should not be the right angle. So the theta will be one of the acute angles. So there are three sides in reference to theta. There's the side opposite theta, there's the side adjacent to theta, and there's the hypotenuse. Adjacent means next to, and so adjacent is just the angle, it's the side next to theta that is not the hypotenuse. So adjacent is the side touching theta, but not the one that's the hypotenuse. Okay, so if you remember SOHCAHTOA, so means sine theta equals the opposite side length over the length of the hypotenuse. SOHCAHTOA. So cosine is the adjacent side divided by the hypotenuse. And the tangent of angle theta will be the opposite side divided by the length of the adjacent side. Okay, get your calculators ready. So for number 1, we have an angle, so that'll be our theta. We want the opposite side, and we know the hypotenuse. So what uses opposite and hypotenuse? Sine does. So sine of 20 degrees will equal opposite side we see an x, and hypotenuse we see a 14. Okay, we're trying to get x alone, so we have to multiply by 14. When you multiply a trig function, so when you multiply sine, cosine, or tangent by a number, you put that number in front. Do not put the 14 next to the 20, otherwise it's going to take the sine of 280 degrees, which is 14 times 20. You want it to take the sine of 20 degrees and then multiply that by 14. Okay, when you turn on your calculator, the first thing you should do is push mode. Mode is next to the second button. And on the third line, make sure you are in degree mode. So I push mode, I look at the third line. I don't want to be in radian mode. I want to be in degree mode. Okay, once you're in degree mode, you could push second mode to quit and type in 14 sine 20. Close the parentheses if you want. It'll still work if you don't. So the answer is 4, and we need to round to the nearest tenth, so it's 4.8. Okay, for number 2, so we have an angle, we have the adjacent side, and we have the hypotenuse. So what uses adjacent and hypotenuse? Cosine does. Cosine of 51 degrees equals adjacent over hypotenuse. Multiply the 8 to the other side. Okay, to show your work, you need to get the variable you're solving for all by itself. That's called calculator ready form. So if you just write the final answer, like for number 1, if you just wrote x equals 4.8, without getting to this step, you would not get full credit. So you need to get the variable you're solving for in calculator ready form, which means the variable on one side and exactly what you're going to punch into the calculator on the other side. So I'm going to punch 8 cosine 51 into my calculator. So x equals 5.0. Okay, we have an angle, 38 degrees. We see the opposite and we see the adjacent. So what uses opposite and adjacent? Tangent. Tangent of 38 degrees equals opposite over adjacent. You should always be putting an angle next to sine, cosine, or tangent. Never put a side next to sine, cosine, or tangent. Okay, it's hard to solve for something that's in the denominator, so we're going to get it out of the denominator by multiplying to the other side. And we're trying to get x alone, so we divide by tan 38. 10 divided by tan 38 equals 12.8. Okay, so here we have an angle. This would be adjacent. That's obviously the hypotenuse because it's across from the right angle. So what uses adjacent and hypotenuse? Cosine. Cosine of the angle equals adjacent over hypotenuse. So this is the same as the last one. We can do two steps in one. The x multiplies to the left side, and then the cosine 63 gets divided to the other side. So 4 divided by cosine 63 is 8.8. For number 5, we have an angle. We have the opposite side to that angle, and we have the hypotenuse. So what uses opposite and hypotenuse? Sine. Sine of x degrees equals opposite over hypotenuse. Okay, this is the first one where the variable is the angle. So a lot of people say divide by sine, which doesn't really make sense. To get rid of a sine, what you do is you take the inverse sine, or inverse sine, also known as arc sine, shares a button with sine. So normally you push sine. On this one we're going to push second sine later. So what that looks like, so on your calculator it looks like sine to the power negative 1. I would read that as the inverse sine. So if I take the inverse sine of both sides, and I could reduce that to 2 over 5 if I want, or I can leave it as 4 over 10. So I take the inverse sine of both sides. That cancels this out, and I get that x degrees equals, so on my calculator I need to push second sine of, and then in parentheses either put 2 over 5 or 4 over 10 will work, and then you'll get that the angle is 23.578 or 23.6 degrees. Okay, and now we have a word problem. Okay, a guy wire, whatever that is 80 feet long, and it's attached to the top of a radio transmission tower, making an angle of 25 degrees with the ground. How high is the tower? round to the nearest tenth. So we draw the tower, and there's a wire attached to the top and going to the ground. Okay, I'll close the triangle with the ground. We know that the wire is 80 feet long, and we know that it makes a 25-degree angle with the ground. How high is the tower? So we want this vertical distance. That's how tall the tower is. So we have an angle, we have opposite of that angle, we have hypotenuse. What uses opposite and hypotenuse? Sine. Sine of 25 degrees equals opposite over hypotenuse. Multiply 80 to the other side. X equals 33.8, and the units are feet. Okay, on the back side, use trig functions to find the values of x and y. Round to the nearest tenth. Okay, so we have to find these one at a time. The first thing I would do is, well, it doesn't matter which one you start with. We'll just go in alphabetical order. Let's find x first. It's a right triangle. We know the opposite of x. We know the hypotenuse of the triangle. So opposite and hypotenuse means sine. Sine of x degrees equals opposite over hypotenuse. Okay, so when you are solving for an angle, you need to use inverse trig. So either inverse sine or inverse cosine or inverse tangent. So I take the inverse sine of both sides, and I'm going to do one less step than last time. So I take the inverse sine of that, and the sine just goes away. I also have to take the inverse sine of this side. Okay, second sine, 7 divided by 15.3. And I get that x is 27.2 degrees. So there's two ways I can find y. One way would be to look at y and realize that I have the hypotenuse, and 7 is adjacent to y. So even though 7 is opposite of x, in terms of y, it's adjacent. So I could use what uses adjacent and hypotenuse. I could use cosine. So cosine of y degrees equals the side adjacent to y, which is 7, and the hypotenuse of the triangle, which is 15.3. But the faster way then to solve that equation would be to just subtract the other two angles from 180. We know that in a triangle, all three angles have to add up to 180. So if I know the other two angles, one was given as 90, and the other one I just found, it's a lot easier to use or to subtract the other two angles from 180 than to use trigonometry. So 180 minus 90 minus my last answer, and I would round that to 62. 62.8 degrees. We have an answer there and an answer there. For the last one, we have someone is standing 150 meters away from a tower. So usually towers are perpendicular to the ground. So there's our tower. Let's have the person standing over here. We know that this person is, or their eyes are 2 meters above the ground, so this is 2. They are looking up at the tower, at the top of the tower. All right, so they give you a vocabulary term that we haven't used before, angle of elevation. Angle of elevation. So an angle needs 2 lines. An angle of elevation involves a line of sight looking up and a horizontal line. So again, angle of elevation, the line looking up and a horizontal line. So the 2 red lines make the angle of elevation. They tell us this is 36 degrees. All right, we know that he is 150 meters away from the tower, and we're trying to find this distance. And then once we find that distance, we need to add the 2, since his line of sight is not from the ground, it's from 2 meters above the ground. All right, so looking at that diagram, we want to know the opposite of the 36 degrees, and we have the adjacent. So we're going to use tangent. Tangent of 36 degrees equals opposite over adjacent. Multiply 150 on the other side. (150) times tan 36 is 109.0. So y equals 109.0, and we have to add the 2 meters. So adding 2 to this, we get 111 point. Actually, they said round to the nearest meter, so 111 meters. All right, that's it for the first half of 12.1.